for number 1, I found where cosine is root 3 over 2, which is going to be 30 degrees or pi over 6, so that's what that looks like. And then found where cosine is 0, which is at pi over 2. That's what that graph looks like. And then found where sine is positive 1/2. It's also at pi over 6. And then for the last one, where sine is negative 1/2, it's going to be the opposite. So it's going to be 5 pi over 6. So for A, I did 2 times sine of 3x equals 1, so added 1 to both sides, and then took the inverse of both sides, so the signs cancel out on the left side, so you get 3x equals, inverse sine of 1/2 is pi over 6, and then plus 2 pi k. Then divide both sides by 3, and you get x equals pi over 6 times 1/3, or divided by 3 is pi over 18, so you get pi over 18 plus 2 pi k over 3. For problem B, tangent squared of x minus tangent of x minus 2 equals 0, you're going to factor that. And to factor that, you're going to do tangent of x, and then 2 times 1. So tangent of x equals negative 1 at 3 pi over 4 plus pi k, and also at 7 pi over 4 plus pi times k. And then tangent doesn't equal 2. For this next one, we're also going to solve by factoring. So 2 times cosine of x on one side, and then cosine of x, and then 3 times 1. We're trying to make it equal negative 7. So 2 cosine of x equals 1. The cosine of x is 1/2 at pi over 3. That's supposed to say pi over 3 plus 2 pi k. And then also 5 pi over 3 plus 2 pi k. And then cosine of x does not equal 3. For B, we're going to do, so it's 1 plus sine of x equals, and then so we're going to make cosine squared of x into 1 minus sine squared of x. So 1 plus sine of x equals 2 minus 2 sine squared of x, and then subtract 1, subtract sine of x, and that leaves us with negative 2 sine squared of x minus sine of x plus 1 equals 0. Then we're going to factor that to solve for x. So negative 2 sine, and then 1 times 1. We're trying to get negative sine, so make both those ones positive. Negative 2 sine of x equals negative 1. Sine of x equals positive 1/2 at pi over 6 plus 2 pi k. And 5 pi over 6 plus 2 pi k. And then sine of x equals negative 1 at 3 pi over 2 plus 2 pi k. For A, r equals 2 plus 2 cosine. So, 2 cosine looks like that, and so 2 plus 2 cosine is going to be the little loop. And then same goes for B. It's very similar. It's 1 plus 2 cosine of x, so we have what 2 cosine of x would look like, and then just plus 1, it's also the loop. And then for C, it's 2 sine theta, so that's going to be vertical, or on the y-axis, up 2. So the first part, we're going to plot them. So the y-axis is imaginary, the x-axis is real, and so 1 plus I. And then if we're going to do 2x, or 2z actually, so z is 1 plus I, so 2z is 2 plus 2i. It's plotted right there. and then 1/2 of z is 1/2 plus 1/2 I, and that's right there. So then next, to find the modulus, a squared plus b squared, take the square root, so it's equals the square root of 2. And then for the next part, I'm going to write out z equals root 2, and then cosine, and the angle there, it's going to be pi over 4, 45 degrees. Cosine pi over 4 plus I times sine pi over 4. And then we also have 2 times z. So multiply all that by 2. Then 1/2 dividing everything by 2 or multiplying it by 1/2. For number 6, so we're going to start by taking, adding the first two equations in the system together. We get 2x plus 2z equals 14, because we're canceling out y. We're going to do the third one minus the first one, to also cancel out y, which leaves us with 4x minus 2z equals 4. Now we have two new equations, so we can do 4x minus 2z equals 4, and add it to the first one, and so we get 6x equals 18, x equals 3. So now that we have 1, x equals 3, we can go back and plug that in to any of these. So we're going to do 2 times 3 plus 2z equals 14. We're going to solve for z now. So 2z equals 8, z equals 4. Now that we know z, we can go back to one of our original equations, plug in x and z to get y. So 3 minus 2y plus 3 times 4 equals 1. So that means y is going to equal 7. So we have one solution for x, y, and z. So for this next one, we're going to start with the same process. So we're going to do 2x plus 2y minus equals 6, so the second equation, and then we're going to subtract the first equation, so multiply it all by -1 in order to cancel out y to begin with. Leaves us with x plus z equals 5. The next step is going to be to take the third equation and subtract the first equation somehow, canceling out y again to give us a second new equation. So we're going to multiply everything by -2 so we can cancel out the y. So it leaves us with x plus c equals 3. So x plus c equals 5 and x plus c equals 3, so they can't both exist at the same time.